All right, so I want to take the time here to revisit a topic that we dealt with briefly earlier, and that is the fundamental theorem of calculus. And the reason why we're coming back to this is because this is actually the last section in the chapter 18 of your textbook, and we're going to go right into chapter 19. But really, to apply any kind of integral to a situation, you're going to be doing some sort of a definite integral. If you remember, when we looked at this before, we said the definite integral has an interval that we want to integrate over, okay? And the fundamental theorem of calculus says that if capital F of x is the antiderivative of f of x, where f of x is continuous on the interval from a to b, that's important, the definite integral of f of x on this interval is the integral from a to b of f of x dx, and it will equal the antiderivative evaluated at b minus the antiderivative evaluated at a. Okay? Now, if you do AP Calculus or Calc in college, there's a lot more. There are other parts of the fundamental theorem of calculus, and there's actually a second fundamental theorem of calculus. This is the only part we're going to use in this course. Okay? Now, if you remember what we said about integrals, integrals gave us the area under a curve. Okay? The area under a curve. So in this case, if we had some kind of a function, and a is here and b is here, then the integral from a to b would give us the area that we have here. Okay? So that's the general idea. And by the way, you can see here why we need it to be continuous on the interval. All right. Consider if our function were like a hyperbola of some sort. You know, we had something like this, and we had something like this. You know, and there was this asymptote down the middle. If A was here and B was here, you know, getting the area would be impossible because, like, what's the area down there as we're approaching the asymptote? We have no idea, all right? So we can't do that. We can't do that if it's not continuous. Has to be continuous. That means, too, it has to be defined on either side. It has to be defined at both of those values as well. Okay? So, let's look at this idea a little bit more closely. Okay? Here I have a function, we'll call this f of x. And I have two values, a and b. And let's call this 0 here, c. Okay? Now, there are two things that you have to be careful to keep straight. Now, you have to be careful because there's two different things that you could be asked to do, or you may want to do, okay? If you're asked for the area under a curve, okay, this is the area between the curve and the x-axis, and area below the x-axis is negative, okay? So, for example, you know, this... let's get a different color we can see. This might have an area of, say, 12, and this area down here might be like a negative 4. Okay? So if I were to do the integral from a to b of f of x dx, that would equal 8. You might say, well, wait a sec, that's 12. How do we have less than 12 if part of it equals 12? Well, it's because when you're finding area under a curve, essentially what you're finding we could call the net area. Okay?
Unless it's like a sinusoidal function, right?
Well, here's the interesting thing. If you have a full period of sine, what would the integral from the start to the finish be? 0, because you have an equal amount on top as you have on bottom. Okay? So, yeah, if we did the integral of sine from 0 to 2 pi, it's 0. Okay?
So basically we don't care about the signs, like for -4, it will still be minus, right? Because it's below the x-axis.
Yeah, it's -4 because it's below the x-axis.
Okay, so we would just take the regular numbers, right?
Mm-hmm. Yeah. So the net area, that if you're asked for area under the curve, you're talking about net area. Now, something we're asked to do quite often instead of area under the curve is the total area between the curve and the x-axis. Okay, and there we don't want the net area, we want a total area. So what we end up doing is we take the absolute value of those areas. Okay? And what we have to do in order to do this, we can't just take the integral from a to b. We have to find any zeros, like I labeled there c, and we would have to take the integral from a to c. And since I know that's positive, I can leave it like that. And then I need to add to it the absolute value of the integral from c to b of f of x dx. Okay?
So from B to C. Okay.
Well, c is to the left of b, so you always go left to right. Otherwise, it'll make it negative. Okay? So from c to b. And we take the absolute value, and that would give us 12 plus 4, giving us a total area bound as 16. Now, depending on what application you're doing, you may want a total area, or you may want the net area. Okay? If you remember when we did kinematics with the derivatives, it's very similar to that, because sometimes you are asked for what's their final displacement, and there we didn't care what they did in the middle, we just said, where are we at the end? That's like net area. We don't care how much is positive, how much is negative, it's just what's left over. Okay? Other times in kinematics you were asked, what's the total distance the object traveled? And you didn't care if it was traveling to the right or to the left, you wanted total distance. So you had to find those turning points, right? So the distance from here to a turning point, and then from that to the other turning point, and then from that to the end, and you made any negatives positive, okay? That's what we're doing here with the areas. We find the 0, which is where we're changing from a positive area to a negative area, and we're just making all the areas positive and adding them up to get a total. Okay? Now, let's actually look at this with an example. And here we have this function f of x, and it's made up of a semicircle, and the semicircle has a radius of 2. And then it has this line segment down here, so there's a point of discontinuity at 4, and there's another one at 6, okay? And then we have another semicircle here from 6 to 8 with a radius of 1, okay? So since we've been talking about areas, let's go ahead and find the areas here. What's the area of this semicircle?
Oh, 4 pi. Wait. Yeah. Wait, no.
It's a semicircle.
2 pi.
2 pi, okay? So 1/2 times pi r squared. Okay? So 2 pi is our area. Okay? Then down here, we have this little square, okay, between the line and the x-axis. Alright, so what's that area? 4. Okay? And finally, we have this little semicircle over here. And what's that area? Yeah. 1/2 pi times 1 squared, so that's pi times 1/2, pi over 2. Okay? So there's a little geometry for us, but let's now relate this to calculus, okay? The integral from 0 to 4 of f of x dx, what would that equal? It would be 2 pi, okay? That's that first semicircle that we found, okay? How about the integral from 4 to 6? It would be a -4, good. The area of that square was 4, but this was below the x-axis, so we would say it's -4. Okay. How about the integral from 6 to 8?
Pi over 2.
That's pi over 2. Okay, now this is interesting because look, how come we can't use the fundamental theorem of calculus to figure out d? It's not continuous. All right.
We can all do it.
Well, we can do it, but we'd have to break it into parts. Okay? We'd have to break it into parts. So we have the integral from 0 to 8 is going to be the sum of those first 3 areas that we just found. Okay? So we have 2 pi plus a -4 plus pi over 2. Okay? So again, the integral, the definite integral gives us the net area, so we leave the negatives negative.
Do we need to have the absolute value when we have -4?
Not here when we're just taking the integral from 0 to 8. Okay? What we would use the absolute value for is if we were asked for the total area.
It'll just say, find the total area.
Yes. Between f of x and the x-axis. Okay? And what would that, in that case, we would need to take the absolute value of x. So it would be 2 pi plus the absolute value of -4 plus pi over 2. That's 5 pi over 2 plus 4. Make sense?
Yeah, won't change it yet.
Okay.
Calculate
No.
when you don't have a graph.
Well, here's the thing. Now we're going to look at using our calculator. You can use the graph, or you can simply do it on the main screen where you're calculating stuff. And I'm going to show you both ways, because those of you who have the TI-83 still, it's going to be easier to do the graph. Okay, the 84, as long as your firmware is updated, your OS is updated a little bit, you could, either way is just as easy. If your operating system's not updated, we could get you updated. That's not too hard to do. Okay.
How do you know?
So let me show you how to do this on the calculator. All right, now. Let's take a look at this. You guys see we're going to evaluate the integral from 2 to 5 of x times e to the x dx. Now, this is a function that you can't do by u substitution. If you were an AP Calc or something, we would do some kind of a trapezoid method or some other kind of approximation method in order to get it. Okay? But you can see the notation there, all right, on the screen that I have. If you hit the math button, which is just underneath the alpha button on your calculator, and then go down to number 9, it says fn int. That's the integral of a function. Okay? Now, on the 83s, you would have to remember what order to put stuff in. you type in your function, you put a comma, then the variable of integration, so we want to, it's dx, so we put in an x, and then your lower bound and upper bound. It's a pretty intuitive order, you know, to put stuff in, but you would have to remember how to do that. On the 84, however, let me show you, okay, on the 84, we want to find the integral of f of x dx. So we hit math, and again, it's down here at number 9. Okay, and you have this little template that comes up for you, and it's super nice, because you just type the stuff in the boxes, all right? None of you have the Nspire, but if you had an Nspire, there's a little template menu just to the right of the number 9 that, that you can hit. Actually, right here, you'd hit this, and then there's a template that will give you this. So at that point, it's the same thing as on the 84. Okay? So we want to integrate from 2 to 5. So we hit 2, hit the arrow over to the box, put the 5 in. Okay? And then we want x times e to the x. Hit the arrow over a little bit, and then it comes over here. Make sure you tell it that we're integrating with respect to x. And then you just hit enter. And there you go. Our area is 586.26. It's really nice. Okay?
So we just put the number in?
And then, yeah, that's your answer. Okay?
So for you, do we need to like put some...
There's no U or DU here because it won't work out. I mean,
you know, show the work. Do we just...
Okay, showing the work on this. If it's something like on the calculator portion of the exam, then a lot of times, if it's something that you could just punch in your calculator, they'll give you full marks for not showing work. One way you can show work, however, is if you do it the graphing way. If you go to y equals and you type in x times e to the x on the graphing calculator, and you graph it, that's what that's going to look like. Okay, now it went off the screen, but as long as the x values in your interval are all showing, it'll work. Okay, we want to integrate from 2 to 5. My window goes from -10 to 10, so my interval is in there. But check this out. Remember how we found intersections and zeros using the second calculate? If we hit second calculate, notice the last thing on here. Number 7 is the integral of f of x dx. So if I hit that, look at what it asks me. It asks me for a lower limit, and you can just type that in. So I type in 2 and hit enter. It asks me for an upper limit, so I'm going to hit 5 and hit enter. And check that out, it even colors in the area for you. Okay? So if you wanted to show your work, so to speak, you could just do a real quick sketch of the graph and show the area that you're finding and then write down your answer. Okay? Those of you with the 83s, this is going to be probably an easier way of doing it than trying to remember the correct order. But it's up to you. Okay? So, really powerful tool that you have there, being able to use your calculator. You still need to be able to do them by hand because you will have ones on the no calculator portion of the exam. But this is a great way to do ones that you can't do by hand very easily, and you can also use it to check your answers. Okay, so if you're doing homework or something and you tried one by hand, you got an answer, throw it into your calculator and you can check to make sure you got it right. Okay. Alright, so we have a little bit of practice here. Some of this stuff they give you a little help with, like number 9, rewrite that, because as it is originally, you can't find the integral of that by hand. You can't do use substitution there. But if you rewrite it in the form of 4 plus 5 over x minus 1, then you can substitute that in and then take the integral of that. Okay? Also, number 10, notice I gave you some that weren't just straightforward fundamental theorem of calculus, because we already did some of that. So here we're kind of stepping up the level of difficulty a little bit, because notice we have a function and we know what we want the area to be. So we're asking, hey, what would m have to be in order to go from m to -2 and make the area equal this? So when you do the fundamental theorem of calculus, you'll be plugging in an m for x and then set it equal to this, and you'll be able to solve it. Okay? This is what, say, a designer might do. And if you're working on a CAD program or something, and you have the shape in the form of a function, and you know like where you want to start, and you know you want it to be a certain area, you want it to take up a certain amount of space, maybe because of the cost or whatever, you can force it to be exactly the area you want by doing something like this, solving for your boundaries. Okay? Like B, we want it to be twice as long on the one side as it is on the other side. Or not twice as long. We want it to be twice as far from 0 on the right side as it is on the left. Okay? So, a couple of things to practice there. I gave you a couple with area interpretation. Not all of these ones are required, but take a look at your required IP. If you're still having trouble with some or you want some extra practice, you can come back here and do the rest. Okay?